Here's problem number 7, sample test 2. A 5-gram bead slides on a curved wire starting from rest at point A. The segment from A to B is frictionless, and the segment from B to C is rough. In other words, it has friction. Let's write that in. This is going to be rough over here. Find the speed of the bead at B if the bead comes to rest at C. Okay. Well, we know we have friction between B and C, and it's not a straight line. It's a curved segment. So we really don't know how to describe friction there. We can describe the work done by friction, but that's it. We have point B here, point C, and point A. We're going to compare the energy between A and B because there's no work done along the way between those points. So the kinetic energy at A plus potential energy at A plus work done along the way equals kinetic energy at B plus potential energy at B. This is for part A. We'll realize that we started from rest, so our kinetic energy at A is 0. And it's frictionless, so there's no work along the way, so our work along the way is 0. We're going to say that our height at point B is 0 height. So we have no potential energy at point B, and there's no springs involved either. So strictly speaking, the potential energy at A will equal the kinetic energy at B. Sounds good. We have mg h is equal to 1/2 mass times velocity at B squared. Masses cancel out. Solve this for the velocity at B, and that's going to be equal to 2gh square root, which would be 2 times 9.8 times 5 meters square root. And that's going to be the square root of 9.8 times 10, which will give us 9.9 meters per second. So that is the speed of the bead at B if the bead comes to rest at C. Okay, part B. Find the energy lost to friction as it moves from B to C. Alright, let's compare our energies between B and C. Kinetic energy at B plus potential energy at B plus work done along the way equals kinetic energy at C plus potential energy at C. In this case, we're going to come to rest at C, so we have no kinetic energy at C, and we define our 0 level as at point B, so we have no potential energy at point B. We are going to have work done along the way this time, so our work along the way is going to equal the potential energy at C minus the kinetic energy at B. That's going to be mg height at C minus 1/2 mass velocity at B squared. That's going to be 0.005 times 9.8 times 2 minus 1/2 times 9.9 squared. I just factored out the mass when I did that. So what do we have? Let's see. A negative 0.147 joules. So that is the work done along the way between B and C. A negative 0.147, which means that we lost 0.147 joules because the work done along the way was negative. So that's the energy lost due to friction as it moves from B to C. Answer.